that we were doing before. Here we go. So we got the same problems. 1 and 2, we're using the sum of two cubes and the difference of two cubes. You know we're going to be using those shortcuts because there's only two terms. They both can be cube roots. And the first one's sum because there's a plus sign in between the two terms, and the second one's difference because there's a minus sign between the two terms. So we'll start with the first one. The goal is to get both terms to have cube roots in them. Oh, my pen's not working. There we go. So this x cubed is already a cubed root. I need to turn this 125 into a cube root. If you don't know your cube roots off the top of your head, you can always take your calculator and put 2 cubed, 3 cubed, enter, 4 cubed, enter, until you get the number you're looking for. We are going to use 5 because 5 cubed is 125. The first term is a, the second term is b, and then I'm just plugging it into my formula. So I have a plus b, x plus 5. Then in my trinomial, I have the first term squared minus my first term times my second term plus my second term squared. And then I just simplify. X squared stays the same. This I simplify to 5x because we always want the number in front. And the last term I simplify to 25. And then I'm done. No more factoring it down. This is as small as it can go. All right, for the second problem, it's the difference of two cubes because there's two numbers. I can reduce them, and there's a minus sign in the middle, so it's difference. But the first number, the leading coefficient, is a 64. Now, normally I would like it to be a 1 because factoring when you have a leading coefficient of 1 is a lot easier. So I'm going to try to take out a GCF to get that first number to be a 1. And if I can't, I just want to make it smaller in general because it's easier to work with. So I can divide both terms by 8. So I'm left with 8. And then this reduces to 8x cubed minus 1. Now I can make this 1 to the third, or 1 cubed. Means the same exact thing as 1. But I still want to look at my first term, and I want to reduce this even more. Well, I know 8 is also 2 to the third power. Bring down that 8. Now I want to start plugging into my formula, but I don't really have a consistent a term yet. I have a 2 and an x here. So let's use that product rule. So I have 2x raised to the third, or the power rule, I should say. So now this can be my a, and this can be my b. Sorry, that's supposed to be raised to the third power, not squared. So then I plug it into my formula. A, which is 2x, minus b, which is 1, parentheses, a squared, 2x squared, plus a, 2x, times b, 1, plus 1 squared. And then I reduce what's in the parentheses. So 2x minus 1 stays the same. Don't forget about this 8 who comes along for the ride. And now 2x squared, use that power rule. It goes to both. So now I have 2 squared x squared plus reduce this to be 2x. And 1 squared is just 1. Take it a step further and reduce what 2 squared is. That's a 4. So my trinomial is reduced. I got my binomial up front. And I got this GCF of 8 that I pulled out right in the beginning. Oh, I don't want my whole answer to be crossed out. There we go. And those are your two examples of the difference of two cubes and the sum of two cubes. One has a GCF, the other one does not. Now number 3. I see that I have an exponent of 3, so it's raised to the cube root again, or the power of 3 again, but I have 4 terms here. So when you have 4 terms, first draw your imaginary line between, like right in the middle, and see if you can find a GCF of the first 2 and a GCF of the second 2. And whatever you have left over after you take out the GCF, you want that leftover to be exactly the same in the first set and the second set. So if I divide, let's see, an x squared, and my highest number would be a 3. I'd put that right in front, and my leftovers would be 12x minus 5. I want that same leftover on my other half of this problem. So in order to have a remainder of 12x minus 5, I would have to be taking out a 7 from this problem. And I'm going to put a little plus sign there to show that it's a positive 7. Now the numbers outside of your parentheses are your GCF. They're going to get grouped together for one part of your answer. And then your leftovers are going to be grouped together for the other part of your answer. So my GCF is 3x squared and a positive 7. My leftover was 12x minus 5. This is where I say stop. This is as factored as it can go. But if you want to check your answer and make sure you did it properly, your highest exponent is 3, so I should have 3 zeros or 3 solutions or 3 roots. However you want to word it, you should just have 3 answers if you solve for x. So if I solve for x for my blue parenthesis here, subtract 7 over and then divide by 3, I get x squared equals negative 7 over 3. And then I take the square root. The square root really means you have 2 answers, a plus and a minus. So there's 2 answers so far. And then in my yellow parenthesis here, I'm going to add 5 over and then divide by 12. So that's 1 answer. And I have 2 right there. So that gives me 3 roots, 3 solutions. My highest exponent is 3, so I did this properly. So this is as small as I can go with factoring. And the question was just to factor. So all right here is just checking your work. We'll call it checking your solutions because we're making sure that we have the same amount of exponents that we have. All right. Number 4, again, I see 4 terms, highest is a cube, but I can't use the difference or sum of cube roots. So I draw my line. I see what I can factor out. So my first side, I can factor out an x squared. That's it. I'm left with 2x minus 7. I rewrite that 2x minus 7 on the other side. I realize that I can take out a 4, and I have to make it a negative 4. Because this is a negative 7, this is a positive 28. I have to divide by a negative 4 in order to change those signs. So my final answer would be my GCFs, which are x squared minus 4, 2x minus 7. I check my exponent. My highest exponent is a 3. I should have 3 solutions. Is there any way that I can break down one of these binomials to be another binomial? And I can. I have the difference of perfect squares right here. So I can have x minus 2, x plus 2. And then that 2x minus 7. So I have 3 binomials, which will leave me to have, if I set them all equal to 0, I'll have 3 answers, which is how many x, the highest exponent that I have. So this would be my final answer. All right, here's another 4-term problem, but my highest exponent's a 5, so I need a lot of answers here. So first I'm going to draw my line because there's 4 terms, so let's see if I can factor by grouping. highest thing or greatest common factor I can take out of my first set is x to the fourth, x minus 3. So I got to realize, what can I take out of negative 16x plus 48 to be left over within x minus 3? I will have to take out a negative 16. It has to be negative because my 48 is positive. Put my GCFs together. Put my leftover right afterwards. And my highest exponent's a 5. I need 5 solutions here. So I have to ask myself, hey self, can I break these down anymore? X minus 3? No way, Jose. Cannot break that down. It's part of my final answer. But x raised to the 4th power, well, 4 is a perfect square, and so is 16. 16 is a perfect square of 4. 4 is a perfect square of 2. So I can break these down to be x squared minus 4, x squared plus 4. Move him closer. So right now I have 3 binomials, but I need 5 answers. But this is a variable raised to the 2nd power, which means at the end when we're solving for x, we have to take the square root, and a square root has 2 answers. So this one will be x equals plus or minus 2 when we solve for 0. Solve for x. This one, after subtracting the 4 over and taking the square root of it, I'll be left with x equals plus or minus 2i, because you're left with a negative square root of 4x, or the square root of negative 4. So when you take the square root of it, can't have a negative square root, so it turns into an I. That's where the I comes from. And this one will be x equals 3. So I have 1, 2, 3, because I have 2 answers here, 4, 5. So this right here is my final answer. This right here is just checking how many solutions I have. Remember, it has to match the highest exponent. All right, the last problem. Now we actually have to solve, or maybe do I have 2 problems? I have 2 more. This one, it's equal to 0, so I have to have a final answer of x equals something. I have 3 terms, so I can't use factor by grouping. I'm going to just factor it like it was a quadratic, like we did in Algebra 1. The first thing I want to look at, just always, is if there is a GCF before I factor. And then I'm going to solve. So a GCF that I can take out of all of these numbers is a 4x. So I'm left with x to the 4th minus 10x squared plus 9. Now I can factor this. Factors of 9 that get me 10 is 1 and 9. It's a negative 10, so both of these have to be negative. So I have x, and I got to break up this 4 too, to be x squared and x squared. So I have x squared minus 1, x squared minus 9, 4x in the front. Now remember, my highest degree is a 5, so I should have 5 solutions. Can we break this down any more? Of course, we have 2 here and a 9, and 9 is a perfect square. Difference of perfect sums. X plus 3, x minus 3. I can make this x plus 1, x minus 1 as well, if you would like. Oh, I forgot my 1. And then I can set every single thing here equal to 0. 4x equals 0, x plus 1 equals 0, x minus 1 equals 0, x plus 3 equals 0, x minus 3 equals 0. That was a mouthful. First one, divide by 4, x equals 0. Subtract 1 over, x equals -1. Add 1 over x equals 1. Subtract 3 over x equals -3. And add 3 over, so x equals 3. So I have my 5 solutions. I know there's 5 because my highest exponent is 5. Okay, last problem that we're going to do together. Again, see if there's a GCF, factor it, and then solve it. I can take out a 3 and an x squared from each number, each term. I'm left with 3x squared on the outside, x to the 4th plus 4x squared minus, what is that, 32? Yes, it is. I'll continue to write equals 0 just as a little self-awareness that you have to set all these equal to 0 at the end. Factors of 32 that get 4 would be 8 and 4. It's a positive 4, but a negative 32. So my 8 has to be positive and my 4 has to be negative because positive 8 minus 4 is a positive 4. And 8 times -4 is a -32. And that x to the 4th is x squared and x squared. So x squared minus 4, x squared plus 8. I see a difference of 2 perfect squares right here. 3x squared, x minus 2, x plus 2, x squared plus 8. I have, my highest exponent is a 6, so I should have 6 solutions. That's a lot. Let's say 3x squared equals 0, x minus 2 equals 0, x plus 2 equals 0, x squared plus 8 equals 0. This guy's easy. Divide by 3, x squared equals 0. We take the square root. You technically, because it's just a square root, you have technically 2 answers. Add 2. Here we're going to subtract 2. Here we're going to subtract 8. Then we're going to take the square root. So you have 8x, not 8. X equals the square root of 8i, because you can't have a negative under the square root. And that's a plus or minus. So you have 2 answers here, 2 answers here, and then these 2 answers. So you have your 6 answers total, which that's your highest degree, so you know you did it properly. All right, let me know if you want me to make a video for the 2.5 problems we did.